Welcome to the next exercise. In this exercise, let us try to create the geometry which is visible on the screen. We have to utilize the Revolve option and create this geometry. At first glance, maybe we are quite skeptical about us, that maybe we are finding this geometry very difficult. But I'm telling you that when we are understanding the procedure, the method and the trick for working with this kind of geometries, then I'm pretty sure that you can design any kind of revolve geometry or any kind of feature or component which requires you to use the command revolve. So basically this is a kind of wheel, and it is a friction wheel, and it has its own diameter. The total diameter is seen in this particular view. There are different arrangements of view. We have the top view over here, we have the three-dimensional view, and we have the side view of the friction wheel. We also have two detailed views, A and B. So A is at this particular location. I'll just zoom in. You can see we have circled one region, as this particular region is having dimensions for each and every turns. So it is quite difficult for us to keep the dimensions over there. So we have to introduce a detailed view in the drawing. So we have to circle it. It is a kind of way of interpreting that this particular A denotes a detailed view at some other location which is closer to this particular area. So we have to assign this particular region in a magnified way, and we can then assign the dimensions for each and every edges or segments. Similarly, we have a detailed view termed as B for this particular region. You can see there is a kind of slot over here which is visible in 3D view. So the dimensions of that particular slot is expressed in the form of detailed view. So let us try to work on it. So first we have to analyze the geometry, and then we have to understand, and we have to make a point, or we have to decide with the procedure of moving forward. So as this particular geometry is a kind of wheel, so we have to utilize the option, obviously we have to utilize the option revolve. And when we are analyzing the views, we have to identify a particular view which is helpful for us to create the swept section. So in general note, if we are trying to create the wheel, I'll just try to show a sample over here. It is a simple technique to create the wheel. I'm just doing it with random dimensions. Okay, so I'll just choose the x-axis. So I'm getting a kind of wheel shape. Okay, so this is also quite similar to that this particular method what I've just drawn over here, but we have to follow certain dimensions. That is the only difference. Now we have to analyze the geometries or the views clearly and identify a view which is suitable or helpful for us to create the wheel. So when we are looking at the three-dimensional figure over here, it is not possible for us to identify the internal section of the wheel. The second view over here, that is the top view, when we are analyzing this view, still we are not able to find out what is the internal section of the wheel. Now let us look at the side view. In this particular view, there are chances for us to understand. There is a possibility for us to understand the internal section of the wheel. Now if I am zooming in for this particular view, you can see that this side view is divided into two regions. The first region is the way how the particular view is looking to us. When we are trying to look at this particular geometry from the side, how does it look like? It looks like this exactly. But what is the internal section? How is it shaped? And what are the different dimensions for it. Everything is listed in the bottom section of the side view. So we have this particular shaded region. So wherever in the geometry or in the views or on the drawing, if you are finding anything or any shaded regions which are visible, try to interpret that that particular region belongs to the cross section of the geometry. Likewise, in this particular view, I am having a shaded region in the bottom section. So this particular shaded region is actually the cross section of the view which we have to create it, and we have to sweep it to create a three-dimensional shape such as this friction wheel. So I repeat again, the shaded region what you are finding on the screen, in the side view of the wheel, we have to create this shaded region and we have to sweep it, or we have to revolve it around the vertical axis or around the horizontal axis, right? So this is the section what we have to create, and imagine this is the horizontal axis. We have to revolve it around it in order to form a wheel. So it is as simple as that. Now for creating this particular section, there are certain dimensions given to us. As we have already practiced a problem where we have to create the base of the section at some particular diametric distance from the center axis. So this is quite similar to this one. So the reason for this diameters given to us is because of the hole in the feature or in the total geometry. Clear? So we have to follow the same procedure what we have worked earlier. That means we have to create the sketch at certain distance from the central axis. So the first line or the first base will be this horizontal line, and we have to place this particular line at a diametric distance of 40 units. Then after this we have to go down and we have to maintain a distance of 70 units. Then we have to go inside at a distance of 10 units, which is mentioned on the right hand side. Then we have to draw a slanted line and we have to stop the slanted line at a distance of 140 units. And the distance with the outer edge and this inner edge is equal to 44 units, which is given over here. Likewise, the base is also having a width which is equal to 100 units. Clear? And after this we have to extend this vertical line at a distance of 360 units, which is the diametric distance. So we have reached till here. This is simple 2D sketching basically. So don't try to get confused by looking at the geometry what we are having. If you are analyzing the particular feature or the particular region of interest, then it is basically a two-dimensional sketch what you have to draw right now. And you just have to revolve it in order to get a 3D shape. Clear? So this is the 2D sketch what you have to draw it. So if when I'm zooming out, you can see that at a first glance, somebody might be finding it very complicated. But the only thing is we have to identify what we have to sketch at first. And that particular sketch has to be continued by using some other commands like revolve to generate a three-dimensional solid model. Clear? So in this particular figures, the total layout what is given to us, we have identified a region which is shaded. So this is the region which is shaded in the side view. And this shaded region is representing the cross-sectional region. The cross-section of the total wheel basically. So generally, in some components as we have designed earlier, we have worked with a component which was having a I section. But this component is not an I section, it is something different. And that is represented with the shaded region. So following the dimensions what are given to us, let us try to initiate the 2D sketching first, and then let us try to convert that 2D sketch into a revolve geometry. Now after reaching this particular point, we have to work on the smaller minor details over here. And this particular section is given in a detailed view, and each of the cuts or the turns, the segments, the edges are having its own dimensions. So when we are reaching at this particular stage, we have to come down and we have to follow these dimensions and create the model. After which we have to just revolve. We will be getting the total friction wheel with us. And the next step will be to create holes over here. We have to create 1, 2, 3, 4 and 5 holes of 75 unit of diameter. And the last step after that will be to create a slot over here. And this is given with the help of a detailed view which is labeled as B over here. So let us try to begin the creation of this 2D section.